Hi students, I'm Instructor Mary and I'm going to be taking us through another topic which is standard form. We're going to be looking at this topic and explaining based on the interactive content that we have here. Now, what is standard form? We can also refer to standard form as what? Standard index, or it can be denoted as a scientific notification. Now, when do we used standard form? It involves writing large or very small figure in terms of powers of 10. So when you have a large numbers and you want to write them, I want to have a short form of it, then we can use a standard form, to reduce it. And so that implies that we are going to be reducing it based on the power of 10. And we can write our standard form in this notation: a multiplied by 10 raised to power n, where the a that we're talking about here, they are positive or they can be negative integers, and they range between 1 and 10. So they can't be more than 10, so they cannot actually be up to 10. So it's going to be ranging from 1 to 9. So that's why we have 1 is less than or equals to a, less than or equals to 10, which means that a fall between the range of 1 and 9. That is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now we have some example here. This is how we can actually write our standard form. Look at this value now. This is a huge number. So if we look at this is huge number. Now if we want to reduce this, we can use the concept of standard form. And how do we do that? You just count the number of zeros that we have, then it denotes how many power of 10 that we can have. So let's look at the number of zeros that we have here. If you look at this, we have 9 zeros. So by the time we are having the power in 10, so it's going to be what? 10 raised to power 9. For this one, we have 8 zeros. By the time we are trying to reduce it, it's going to be 10 raised to power 8. Now, if you want to get the actual value for this, you can then try and see. Let's multiply 10 in 8 places. So if we are multiplying 10 in 8 places, we are going to have 100 million back. So the same thing applies to this. 10 raised to power 7, that implies that we are having 7 zeros. 10 raised to power 6, we are having 6 zeros, which give us what? 1 million. Now 10 raised to power 5, that implies that we are having how many zeros? We are having 5 zeros, which give us what? 100,000. Now the same thing for the decimal point as well. When you have 0.1, that implies that we are having a negative value for 10. So the negative value for 10 here is what? How many zeros do we have here? Which is just 1 zero. So that implies that we are having a negative power of 10. So this zero is going to be taking minus 1, because it's actually a negative power. This is the decimal point. We are converting this from fraction to decimal, and we have been taught prior in these classes, in the previous classes rather. So if you look at this now, this is 10 raised to power minus 2. That implies that we are going to be having 2 zeros. So if you look at it, we have 0.0, and the same thing applies to 10 raised to power minus 3. That is going to be giving us 3 zeros, but you have to write a 0 before the decimal point. 10 raised to power minus 7 as well. That's going to be giving us 7 zeros before 1. But there must be a 0 with a decimal point before we can write the remaining 0. So this is an example of how we can actually write our standard form. So we can express our standard form in this form. We have a huge number, we have huge figures, and we want to reduce it, then we write in standard form. Now if we have an activities here, we have to write 72,000 in standard form. Now based on the explanation we have before, we have how many zeros there? That is how many zeros? This is 3 zeros. But remember that the place value of this figure is 4, because this is 72,000. So by the time we are expressing, it is already in 10,000. So 10,000 is having how many zeros? 10,000 is having 4 zeros. So by the time we are expressing this, it's based on the values that we have here. So it's going to be giving us 7.2 times 10 raised to power 4. 7.2 times 10 raised to power 4. Now we have another example here. We have to express 4 times 10 raised to power 4 in an ordinary number. So 10 raised to power 4, that is how many zeros? 10 raised to power 4, that is 10 times 10 times 10 times 10, 10 in 4 places. So by the time you multiply 10 in 4 places, it's going to give us what? 10,000. So if you are multiplying 4 now with 10,000, that will give us 40,000. So 4 multiplied by 10 raised to power 4 will give us 40,000. Look at this. This is a decimal standard form expression. So let's count how many zeros we have here. This is 4 zeros. So if we are expressing this, this is going to be taking a negative powers of 10 because it's expressed in decimal point. Now, so we are going to be expressing this as what? As 5.6 multiplied by 10 raised to power minus 4. Why do we have minus 4? Because we are expressing in decimal point. So this is going to be the answer for this. Now, let's check if we are right. So we are right now. That takes us to the next content we have here. This is factorial indices. When are you talking about factorial indices? This is when you have a fractional indices in powers of fraction. When you have indices and we are raising it in powers. So then we can refer to that as a factorial or fractional indices. A negative and the fractional rules of indices are being applied. So whenever we have indices in power of fraction, the index number is in fraction, then we make use of negative rule. Now let's look at the rules that we have here. This is a, which is the base number, raised to power 1 over 9. By the time we are writing this, you can write it as n root a. So we can have it as n root a or a root n. Now this is another one here. This is a raised to power n over m. So if we are writing this, it's going to be what? N root a, everything raised to power m. N root a, everything raised to power m. Or we can also express this as well. This is also a, this is a raised to power m root n. Now, if we have that, we are going to be looking at this example. We are going to be solving it together. Evaluate 25 raised to power half, everything raised to power 3 without the use of calculator. So we are going to be solving this and see. Then the second one says that we should ever solve 32 raised to power x equals 2. So we are going to be solving this together. So we are solving this and let's see the solution. Quickly, let's solve. For the first one, we have 25 raised to power half, everything raised to power 3. Now remember the root of whenever you have something like this, a 1 over n. We can write it as root n a. So we can have this as root of 25, everything raised to power 3. Now, what is the square root of 25? The square root of 25 is 5. So we have 5 raised to power 3. Now, what is 5 raised to power 3? That is 5 in 3 places. 5 times 5 times 5, which is what? 125. So for this first one, the answer for this first example here is what? 125. Now let's solve the second one. This is 32 raised to power s equals 2. We have a base number of 2 here. So we look at how can we express 32 in a base number of 2 as well. So how many times can we multiply 2 to give us 32? That is 5 times. So it's going to be 2 raised to power 5. That is 2 times 2 times 2 in 5 places to give us 32. So 2 raised to power 5. Remember, we still have our x. We have our x there and we have 2. So when we have that, we can now cancel this and this. And remember this one, 2 cancel 2, we still have what? Well, here we have 1. So we have 5x equals 1. What do we need? We need to know the value of n. So with the x, we divide this side by 5, we divide the other side by 5. Now if you look at this, we have a common number which is 5 here, so it's cancelled each other. So cancelling each other, x will give us 1 over 5. So for this second expression, which is 32 raised to power s equals to s will give us 1 over 5. So with this note, we are going to be dragging the correct answers to each boxes. So let's drag correct answers to each. Now let's drag. For this one, root 25 is what? 5. So it's going to be 5 raised to power 3. That's root 25. Now 5 times 5 times 5 times 5, that is what? 125. So we have 125 here. And for this one, the final answer is what? 1 over 5. So we have 1 over 5 coming here. Let's quickly check we are right. So that leads us to the next example here. We are going to be explaining this also in a short while. So let's solve together. So let's solve. This is 2. We have to find the value of x if 2 raised to power x equals 32. So 2 raised to power x equals 32. Now, how many times can we multiply 2 to give us 32? That is 5 times. So it's going to be 2 raised to power x equals 2 raised to power 5. This one we cancel this. We have x left here. So x equals to be 5. So that is the answer. X equals 5. That's the answer. We have x. So let's drag the correct answer to each boxes. Now, 32 equals what? Equals 2 raised to power 5. And our final answer is what? X equals 5. So let's check x equals 5. Let's check. Okay, now that leads us to the next one. We have another example here. We are going to be solving that quickly as well together. So let's solve. Let's see what we have by the time we solve the question. So we are going to just be solving and we can start to drag in the right answers like that. So let's look at it. Find the value of m if x raised to power m minus 1 equals 81. So 3m minus 1 equals 81. Now let's look at it. This is the base number here, 3. So let's express this one as well in base number of 3. So 3 in 4 places will give us 81. So we can have 3 raised to power m minus 1 equals to 3 raised to power 4. So having that, 3, we cancel 3. We have m minus 1 equals 4. Now, since we have minus where is minus 1, is crossing to the other side, it changes to plus 1. So we have m equals to 4 plus 1. So m equals to 5. So this takes us to the end of this lesson. We want you to subscribe to our channel www.edubbey.com to get full interactive book for this content. Thank you for listening.